So first of all, I'm here with Ray Montalvo, Principal of Consolidated Energy Design, who is our first new client under the reorganized incubator. And Consolidated Energy Design, maybe you just want to say a little bit about your history as a company and your new product, which is called FADRS. And I'll actually have this brochure for the Advisory Council to be able to show them that this is a fully automated demand response and demand reduction system. And it's your own invention. So why don't you talk a little bit about the history of that?
Okay, well, to understand the history of FADRS, you have to understand a little bit about the history of CED. So CED, which is just an acronym for Consolidated Energy Design, has been in business for 23 years. And we've been in the energy consulting business. But we've also been in the design build aspect of that business. So we've done well over 6,000 projects, most of them HVAC related, all of them energy related, and many of them with control systems. We started doing control systems about 40 years ago, actually, and then, you know, as controls evolved with the introduction of the PC Junior and Apple computers, we started to get involved in energy management, which is what it was called at the time. Then I got into building automation, which is where we would take a computer system to run all of the HVAC and lighting in a building. So we've been doing that for a long time, and somewhere in 1980, I decided that I wanted to get involved in doing demand reduction for a building. So the building I chose was a DOE project called, well, it was a restaurant in Long Branch at the time. Essentially, we had put in 183 evacuated tube, high technology, high temperature collectors that could actually make steam. And we used it for heating domestic hot water and also some amount of space heating for the restaurant. But in addition to that, we had a control system wherein we did demand rolling, where we know that demand in the summer, KW demand that is, it represents about 30% of the electric bill. So we knew that it was important for us to be able to reduce that demand significantly. So we tried to reduce it by about 20%. So we felt that we could comfortably run the building, which incidentally was called the Sea Loft Restaurant for those of you that are from the Long Branch area, by 20%. So we figured that at any one time we would only have 80% of the air conditioning and heating and lighting on, and cycle off the other 20% for 15-minute periods, because that's how the electric company bills. And then 16 minutes later we would turn those pieces of equipment on and turn off other pieces of equipment. And we keep doing this ring around the rosy routine to save money and KW demand for the client. And by default, it also saved money on KWH usage. So that was 30 years ago. Then 10 years ago, before the towers came down, I saw the need for a system that could be able to take that to another level and be able to save money on energy all the time, to be able to dump unnecessary kilowatt usage in a building on a demand for that or a request for that from the local power grid. Now in our area, the local power grid is the world's largest power grid. It's a PJM grid. They operate in 13 states plus Washington, D.C., and New Jersey is one of those states. They have 500 members and 51 million customers. And they've selected FADRS as the platform that they want to use for demonstrating fully automated demand response, because currently they do it in this old-fashioned way of sending an email and making a phone call to these 500 members to let them know they're in trouble. Clearly, in the 21st century, that's not the way we want to go, and so I developed this technology over an 8-year period of time to respond to those kind of events, and it wasn't called smart grid technology in those days. It was called price-sensitive load management, where we would actually look at how much money it costs us to make electricity with an asset like, say, a distributed generator, and how much it costs us to buy electricity. So we had a decision point. If it costs us less money to make our own electricity than to buy it, then this system that I was developing would go ahead and turn that on. But as the years went on, during the course of my developing this, I saw that there were other good applications as well. So whenever the grid got in trouble and in what was what's called a capacity event, where they give you 2 to 3 hour notice, then you can dump power. People felt, oh, we can do that. You know, we don't need human. We can do that with humans. We don't need a machine to do that. But I just have a customer just the other day that on July 7th of this year, when we had a capacity event, lost $80,000 because the humans that were in their 3 facilities couldn't do exactly that.
Right.
Had they had FADRS in place, they would have not lost any of that money because it would have all done it all automatically.
Right.
You know, because FADRS doesn't take vacations. Like one of the guys took a vacation, didn't tell anybody, and other people got too busy doing other things, and FADRS doesn't get too busy doing other things. It just gets the job done.
Right. Right.
So
I talked to somebody the other day who worked in a big building in New York City and said, yes, what would happen on really hot days is the engineers would come running around from floor to floor saying, you've got to turn this off, you've got to turn that off.
Yeah.
And it was kind of a crazy thing to expect all that to work, using human communication when people are busy doing other jobs.
Yeah, and not only that, I mean, yes, everybody's got a PDA or a cell phone, but what if you're in a part of the building where you're not having good communication? Right. What if your battery's down? What if you're not near your computer to get that email? If you're not near your fax machine to get that fax announcement, right. Or you're not near a phone that you can actually hear. So there's every reason in the world not to do demand response with humans. It's better to do it without humans. Now, that's in a 2 to 3 hour head start. Then they have another program called synchronous reserves where they only give you a 10-minute head start. Forget about human intervention there. That is absolutely has to be done by a computer. So our system does that. Whenever the power grid has to buy electricity for a higher number than they really want to pay for that electricity, they give you a 5-minute warning. And if you can be able to power down your building for an hour, they'll give you market rate for electricity. Right. So the bottom line is our system can be able to give people a secondary income stream of $100,000 plus per megawatt per year. It's a lot of money, and it's a shame to waste it, especially when these programs are there. And most people don't know about those programs, and those people that do know about them cannot take advantage of them. Right. So FADRS helps them take advantage of them. Now, FADRS also was built on the philosophy that it's nice to get a secondary income stream, but it's even better to save money all the time, 24/7. So with 40 years of controls experience and a lot of algorithms, in our toolbox, and some prediction technology that I introduced into our artificial intelligence platform, we're able to save people anywhere from 20 to 40% on their utility bill all the time, and then get the secondary income stream as a bonus. So that's what FADRS does, and so now I think it's going to pretty much revolutionize the market. I mean, there's other players in the market, but they do pieces of this smart grid. FADRS is probably the most robust solution in the country.
Right.
It does everything from end to end. And it doesn't only tell pieces of equipment to power down when, so that the grid can stay reliable and not have any brownouts and blackouts. But what it also does is it enables people to take advantage of other income streams as well. For example, solar and wind are Class 1 renewables.
Right.
That's wonderful. We love those things. I've been putting in solar since 1972. But the problem is, the ugly little secret that everybody doesn't talk about is that solar and wind are variable loads.
Right.
And because they're variable in nature, they create a problem on the power grid. And the problem is with the frequency. And they can't keep 60 hertz without a whole lot of work. So what the power grids all across America have decided to do, especially in California and New Jersey, where we have more solar than anywhere else, is give a lot of money as an incentive if you can help them regulate the frequency. So we've been working on that program with PJM. We're almost done with that, and we're about ready to demonstrate. And in that scenario, we would actually power up a set of batteries from the sun, another set of batteries also from the sun, and we'd use them for two separate reasons. The one set of batteries we would use strictly in the frequency regulation market. FADRS would get a signal every 4 seconds from the grid. Either we discharge power from the batteries into the power panel or suck electricity out of the power panel every 4 seconds. This happens about 7.8 million times in a year. So you have to have batteries that are built to cycle that many times and still be able to live a long time and provide the end user with a good payback. But the money is huge. It's like $307,000 per megawatt per year.
Wow.
So it's silly not to really take advantage of that program.
Right.
FADRS is working in conjunction with some other pretty talented groups to be able to turn that into a reality.
Right.
The other thing is, on the same job, we can have another set of batteries that we can power from the sun, and in the night or whenever it's raining or whatever, and as long as those batteries have been charged for free by the wind or the sun, we can use that power in the demand response programs that we were just talking about before, in addition to powering down unessential loads. So there's a very bright future for people that want to enter this field. It's going to create hundreds of thousands of jobs in New Jersey and all over the United States and all over the country. It's going to help our grids. It's going to really help Americans to see that, hey, we don't need to build that many more power plants. We don't really need to increase our infrastructure tremendously if we use less and if we manage the load on the grid. And essentially that's what I've devoted myself to doing. And so 2 years ago I applied for a patent for FADRS. Then I commercialized FADRS in August of last year, 2009. And in the building that, the first building to get FADRS was Gaming Laboratories International in Lakewood, New Jersey, at their world headquarters. We're now saving them 35% on their 24/7 energy bill.
Wow, that's great.
Yep, and also participating in the demand response programs. So that's just one way that we can be, and that's concrete